So there are 4 possible types of carbon in a chemical compound. And I say possible because they may not be all present in with the same compound. You might have a primary, a secondary only. You might have a primary, a secondary, a tertiary. You might have all 4. So let's look at what we call these different types of carbons. So you have primary, you have secondary, you have tertiary, and you have quaternary, 4. So obviously a primary means it's bound to another carbon, 1 other carbon. Secondary, it's 2. Tertiary is 3 other carbons, and quaternary is 4 other carbons. And correspondingly so, the hydrogens can be classified as primary, secondary, and tertiary. This language is very, very important to remember because we will use it all the time when we talk about reactions. This is a tertiary carbon. How does that affect the rate of SN2 reaction? So you will see this in chapter 6 and beyond. But let's look at an example here. So you can take a minute and pause and kind of determine which one would be a primary, a secondary, tertiary, quaternary carbon, and then of course the hydrogens as well. So if you would like to try this, you can pause and then replay it to check your answers. So if we start, this carbon right here, this carbon is attached to 1 other carbon right here. So this would be a primary carbon right here. This carbon is also a primary carbon. It's only attached to 1 other carbon. And that one as well. Are there any more primary carbons? Yep, there's this one, that one too. So you have 1, 2, 3, and 4. And of course, you have the 5th one right there if you haven't seen it. Once again, the bond may not be shown, but it's just a carbon attached to 1 other carbon. So in this case, you have 5 primary carbons. Let's use a different color now for other ones. Do we have a secondary carbon? We keep looking and looking and looking, and we see that this carbon right here is attached to this carbon and that carbon. So that would be then a secondary carbon. So in this case, we only have 1 of them. There's no other one. Tertiary. Let's use a different color. So this one right here is a tertiary carbon because it's attached to 1, 2, and 3. 3 carbons. So that's your tertiary carbon, and you only have, again, 1 of them. So I'll highlight the carbons on the tertiary so you can see them. So you see the 3, 1, 2, 3. That's an H right here. So that's what it means, tertiary. And then, of course, lastly is, and let's actually erase this highlighting, at least on this one. Let's see if we have any quaternary carbons. So you're looking for carbon attached to 4 other carbons. Well, let's see. This one, here's 1. That's the only one that remains. That's 2. that's 3, and that's 4. So this carbon right here is attached to 4 other carbons, and that would be a quaternary carbon. 1, quaternary. Quaternary carbon atom. Now, one rule of thumb here is this going to help you unless we have any other atoms attached, is that if you have to point out the hydrogens, then you have pretty much all the information available here. So let's look at one of the 5 primary carbon atoms. If you notice here, like this one, it has 3 hydrogens attached to it. So again, look for the carbon atoms that are primary, and the hydrogens attached to them are going to be the primary hydrogens. So here's a primary hydrogen, a carbon, then I have primary hydrogens. It's as simple as that. Then I have you have primary hydrogens. Now, I didn't say how many. Of course, you have 3 because the carbon needs, again, 3 bonds to satisfy the octet rule. Here you also have a primary hydrogen or primary hydrogens. Here as well. Okay, this is primary, doesn't mean 1, it means the degree here. Of course, the secondary carbons, and of course, to find the number of hydrogens, you usually, if there are no other atoms, you multiply by 3. So in this case, if I have 5, it would be 5 carbons that are primary times 3, and that would give me 15 primary hydrogens. So here it is, 3, 6, 9, 12, and 15. For the secondary, again, if there are inspected, make sure there are no other atoms like halogens or anything with whatever it is, oxygen, and just inspect it. For the secondary, then you would multiply it by 2. So you would find that this one right here, that's secondary, it has also secondary hydrogens on it. So the rule here is you take the 2, you multiply it by 2, and that would give you 4. Or wait a second, we only have one primary or one secondary carbon. So that's 1 times 2. There are only 2 hydrogens that can be attached, and that would be a 2. 2 secondary. We put this in parentheses so you don't confuse it. 2 secondary hydrogens. They're right here. And for tertiary, just look for the ones that are tertiary, like the one right here in the middle. That right here is your tertiary hydrogen. So you only multiply this by 1. You only have 1. So you'll have one times 1, and that would be 1 tertiary hydrogen. Do you have any for quaternary? No, because there are no bonds that can form between carbon and hydrogen, because it has the octet rule. So it should make sense. You start with 3, you decrease it by 1, it's only 2 then, and then it's only 1, and then it's 0. If you have knowledge, I don't like shortcuts. I mean, there are shortcuts here, but if you have knowledge of the octet rule, then you see the pattern right away.